Hello friends, in today's question, a particle of mass m is projected from the ground with an initial speed of u0 at an angle alpha with the horizontal. At the highest point of trajectory, it makes a completely inelastic collision with another identical particle which was thrown vertical upward from the ground with the same initial speed u0. The angle of the composite system makes with the horizontal immediately after collision is. So we have two particles having the mass m and both are projected, one at an angle of alpha with the horizontal and another with vertically upward with the same initial velocity u0, and they strike when at the highest point of the projectile. So let us draw the basic figure. So this is suppose our particle which is being projected from point O, and it is making an angle alpha with the horizontal. Initial speed is given as u0, velocity is given as u0, and let's suppose B is its highest point. At point B, it is going another particle which is projected, let us suppose, from point A vertically upward with the initial velocity of u0. They're both going to collide inelastically, and we have to find out what will be the composite velocity angle with the horizontal. Okay. So it is given that let us call this as the particle projected from point O at an angle alpha with horizontal. It is called as particle 1, and particle which is projected vertically upward from point A. Particle projected vertically upward from point A is called as particle 2, and they both meet at point B, sorry. Particle 1 and particle 2 collide with each other at point B. So this height will be the maximum height. So this will be h max. So it means the maximum height of the projectile, or we can say particle 1, will be h max, as well as the vertical height maximum taken by the particle 2 will be also h max. You can say height traversed by particle 1 is equal to height traversed by particle 2, and this is given as h max. And we know that maximum height of the projectile which is given as h max is equal to u naught square sine square alpha divided by 2g. Now it is said that both particle 1 and particle 2 meet at point B. Therefore, we say let the velocity of particle 2 just before collision is given as V2. So we can use the equation of kinematics and find out what will be the value of V2 using equation of kinematics. V square is equal to u square plus 2as, where V is given as V2, U is our U naught, A is minus G, and S is equal to H max. We substitute the value for H max, and H max is given as U naught square sine square alpha divided by 2g. We substitute value, we get V2 square is equal to U naught minus 2g, and we get U naught square sine square alpha divided by 2g. 2g cancels out, so we can write this as U2 square is equal to U naught square, we can take as common, this will be 1 minus sine square alpha. 1 minus sine square alpha is cos square alpha, so we can write this will be equal to U naught square cos square alpha. Therefore our V2 is U naught square, U naught and cos alpha. Let us call this as equation 1. And we also know that at the highest point of the projectile, the entire velocity of the projectile is horizontal. You can say that at the highest point B, the particle 1 will have only horizontal component. Of velocity. And particle, let us suppose that is given as V1. So V1 will be equal to U naught cos of alpha. Now it is given that a collision is inelastic. Okay. It is given collision is inelastic, therefore total mass after collision will be equal to 2m. So we can draw the figure. We have at point B, suppose at point B they are going to collide with each other. So this is point B. They are inelastic, so this will be 2m, and we are going to have at point B there will be only a horizontal component, that is v1 in this direction, and another particle, that is particle 2, which is traveling vertical upward, is also having mass m, and it is having a velocity just before collision. Its velocity is v2. And we say, let us suppose this is our horizontal, and this composite system makes and travel in this direction with the velocity of v, making an angle of theta with the horizontal. Okay. We say that after collision, the velocity of the system is v, and making theta angle with horizontal. Okay. Now we are going to use conservation of energy, okay, and conservation of momentum, sorry. Okay. So we can say using conservation of momentum, you can say that initial momentum is equal to final momentum. Initial momentum is equal to final momentum, or we can say Pi is equal to Pf. Now let us consider that the initial momentum in x direction will be equal to final momentum in x direction, and initial momentum in y direction will be equal to final momentum in y direction. So this will be our Vx, and this will be our Vy, and Vy will be equal to V sine of theta, and Vx will be equal to V cos of theta. So we can say in x direction we can write that mv1 in x direction plus mv2 in x direction is equal to 2m velocity in x direction. And velocity component of this is our x direction, and this is our y direction. So v2 does not have a x direction component, and therefore you can say that v2x, you can say, but v2x is equal to 0 and vx is equal to v cos of theta. And you can also say that v1x is equal to v1. So we substitute the value, we get this as m v1 plus 0 is equal to 2m v cos of theta, and m cancels out with m. So from here we can say that v1 is equal to 2v cos of theta. And v1, we already found out that value of our v1 is our u cos of alpha. Okay. So here we can say that v1 is equal to u naught cos of alpha. So we substitute here, we get u naught cos of alpha is equal to twice v cos of theta. From here we can find out value of v. So v is equal to u naught cos of alpha divided by 2 cos of theta. Let us call this as equation number 2. Similarly, in y direction, we can say m v1y plus m v2y is equal to 2m vy. But v1, you can say, but v1y is equal to 0, v2y is equal to our v2, and v2 we already know as per equation 1 is u naught cos of alpha. So this is u naught cos of alpha, and v of y is our v sine of theta. So we substitute the values, we get the equation as in y direction, we can say P initial in y direction is equal to P final in y direction. And similarly, we can write it here also. In x direction, P initial in x direction is equal to P final in x direction. So you substitute the values, we get this as Vy1 is 0, so this will be V0 plus m u naught cos of alpha is equal to twice m v sine of theta. So m and m cancels out. So from here also we can say v is equal to u naught cos of alpha divided by 2 sine of theta. Let this be equation number 3. So from equation 2 and 3, you can say from equation 2 and 3, we get u naught cos of alpha divided by 2 cos of theta is equal to u naught cos of alpha divided by 2 sine of theta. And from here can say that sine theta oblique cos theta is equal to 1, or we can say tangent of theta is equal to 1. Therefore, we get theta is equal to pi by 4. This is the angle with the angle of the system which was asked, that what will be the, it was asked the angle made by composite system with the horizontal immediately after collision. You can say this is the angle made by composite system with horizontal immediately after collision. So option A is the correct option. Okay, option is the correct. So here we can say that option A, option A is correct. So this completes the question. Thank you.